Can you hear me? Hello, everybody. Dear attendees of the International Summer School on Data Science in Software Engineering, we are happy to see you joining our online event organized by Laboratory of Software Testing at Tomsk Polytechnic University with the technical and information support of Exactpro company. This is the third summer school organized by our department and the second international school in English language this year. And we believe that this school will be very interesting, inspiring, and practical for you too. So to begin, let me introduce the first speaker and the program chair, Rostislav Yavorskiy, Director of Computer Science and Robotics School at Tomsk Polytechnic University.
Okay, thank you, Anna. Hi, everybody. Can I ask you just to put something like any sign in the chat, just to be sure that you hear me? And meanwhile, I ask the support to put my slides on. I hope you should have them. Yes. Okay. Cool. So, right, we are starting, yes, slightly later, but perfect. So, we are starting our international summer school. As Anna said, it's our kind of regular job, organizing different conferences at school. And yes, I assume you saw everything. And we'll try to keep all the relevant information on this web page. So once you need something, just go to this timepad web page of the school. You'll see the information, the most recent updates to the schedule, the contact of the organizers, namely Anna. Now you've seen her. So a couple of words about our goals, why we do all this stuff. And here are quite straightforward answers. First of all, we really need our students and our potential students and our colleagues and everybody in the world to broaden one's horizon on the topic of data science and software engineering, to get new friends from colleagues and from friends from students and lecturers, and get new contacts. And we really encourage you to contact everybody here and maybe discuss lectures and ask questions, whatever. And then, yes, the school will be interactive, so it's not just watching a video on YouTube. You'll have opportunity to ask questions, so just don't hesitate to write anything in the chat, and I will be happy to read and to answer. And yes. And yes, the last but not the least, our goal, we start another new master degree program this year. It will be called exactly as the title of the school, Data Science in Software Engineering. And one of our goals is to promote this master degree program, to invite you to join us in September and ask questions, whatever, to see the topics, etc. So a couple of words about our university. This year we celebrate 125 years. So it was established in 1896 by Emperor Nicholas II by his decree. Since that, we had a huge history, and definitely universities like to mention the results in different rankings and participation in all international communities and associations. Definitely, we have all this stuff. And the third line on the slide is just some of our major partners of our universities: Gazprom, Rosatom, and the Russian space industry, oil and gas, and numerous smaller, but probably sometimes even more important partners. And the key partner for this topic, for this master program and for this school is Exactpro. It's now it's huge. Okay, not huge, but rather big international company with center in London, and partners all over the world. And Iosif Itkin, director of this company, will have next lecture. So just use this opportunity to talk to him, to ask questions, and he will talk about the the era of the business. So now about the definitions. Data science is rather new topic, so it probably appeared like probably 10 years ago, not more. It was born as intersection of three following disciplines, namely mathematics and statistics, which had a long history of data analysis and everything related to that, of probability theory and statistics and all these methods and tools. The other parent of the data science is computer science, which contributed everything related to computing, to software, to development, to architectures and algorithms. And what's really important to understand, there is no such thing as data analysis in general, because each time when you analyze data, you need to really know the domain from which this data comes. So it's really important if you're really going to be an analyst or data scientist, to, in addition to basic knowledge of mathematics and computer science, you'll also need to know the business domain of the data. So the interaction of the three is the regions is data science, and in fact it exactly describes our plans for the lectures and for master's program and for this school. We'll have some lecturers who will speak more on business domain, more on computer science, or more on mathematical methods and statistics. Just enjoy, but you should understand that all these are necessary parts of the topic. So this is about data science, and the school is called Data Science in Software Engineering. Software engineering is again a huge area which includes different activities, different skills, different professions, and some of them are listed here, like planning, management, development, design, verification, validation, and actually each of the subfields needs data analysis to be more productive, to be more efficient. So our goal is to develop data science methods and tools which will help people in software development, in software in quality assurance, in design, in programming, in testing, whatever. So that's actually the basic goal of the school. And okay, virtually, but anyway, welcome to Tomsk. It's in the middle of Siberia, really nice town, and hopefully after this pandemic period, you'll be able to visit us. We'll be happy to see you here. So this is my short introduction. Any questions, comments, ideas are welcome. And if no, I'll switch to more serious part of my talk, namely to my first lecture. And okay, no comments, but at least some sign I welcome, like plus or like whatever. Just it's quite difficult for a lecturer to work without feedback. So just any sign would be appreciated. Okay, perfect. So now we switch to first lecture. I will speak about hybrid teams of virtual assistants, robots, and humans. This talk is more like high level, just to give you some probably insights and ideas just to think about. I will be really happy to hear any comments and questions, whatever. So just each time you don't understand anything on any slide, or you don't agree with my statement, just write. I will be happy to discuss. Because the topic is really quite deep for me, quite interesting. I would be happy to have kind of seminar with it quite regular. So, okay, first slide. Yes. First, I would like to ask you to think about skill profile of a computer engineer. When I write computer engineer, I mean something general: software, hardware, data science, whatever. So each of you probably at some point will write your resume, right? Will send you to some place just to find a good job. And what people usually write on this piece of paper. So surely there are numerous services on the web which help you to build your perfect resume, but the basic blocks are usually the same, right? You describe your employment history, education, your references, and then your basic skill set, right? So I know programming, logic, software, whatever. And so my question is, what is the evolution of this skill set during the time? Because clearly, like 10 years ago, the skill set which was expected from a good employee was completely different. And 20 years ago, it was again different. And there is quite clear that in 10, probably even in 5 years, the skill set will be different. And so the question is, what will be expected from a good employee, and what should we study? What should we teach? And let's go probably slightly into the history. So computers appeared just in the middle of 20th century, right? I assume you know some basic of the history. And at that time, assume you meet your friend and say, you know, I'm doing computing. And then it will be clear that doing computing means doing hardware, right? So you know how to connect all these lamps and semiconductors and build all these huge systems. And that was basically the meaning of being a computer engineer, like to know hardware. Then like maybe 10, 20 years passed, and hardware became commodity. Like, okay, there are vendors who produce hardware. What's the problem? Surely you need to study, you need to understand some basics, but to be on the edge of the computing is not doing hardware. So there was kind of the era of algorithm and mathematics. So you'll have to know all these data structures and algorithm and programming languages. And at that time, for people, it was quite clear that computer science is kind of subfield of mathematics. And for many people, I do remember this time, when you say I'm doing computer science, they said, okay, you are doing discrete mathematics. So it's not exactly the same, but it was not clear the difference. So, and many people believe that in order to be a programmer, the perfect way for you is to be a PhD in math, then you'll be a perfect programmer. But then again, after some time, programming and algorithm became something obvious. Like every high school students know how to write basic algorithms. So what's the problem? Okay, indeed, to be a good software developer, you need to study more. But again, building algorithm is not something really difficult. It's kind of basic skill of the 20th century, I mean, end of the century. So the next level was networks. So when internet appeared, it was kind of new big thing. And if you say, you know, I'm really cool a computer engineer, people said, okay, probably you really understand what all this TCP, IP, and all these fancy words, and you know how to connect this wire, or this is really cool. So at this level, at this period of time, to be a computer engineer was something like to understand networks, right? And that was exactly the skill set you would write on your resume to impress someone. You know, I know how to work internet, I know how to write HTML and to build client-server application. That was really cool. You know what's client-server architecture? Wow. But then again, after some time, client-server architecture became something like from basics. And but the system became very complicated and complex. So to be a computer engineer on the edge was to be an architect. So it was at some point it was kind of clear the career path. So first you are kind of an intern who just fix bugs and do some testing. Then you become a developer. You know how to write down a code for some function, how to test it, etc. And then kind of highest level of your dreams is to become a software architect, the person who understands not just one block, not just one connection, but the system as a whole. And that's really cool. And if you know something from software architecture, you put it on your skill set, and then you are kind of happy because everyone wants you, everyone wants the skill. But again, at some point, all this became again like okay, every computer science university teaches this, and after going through some courses, you are happy with you know enough from software architecture. So what was the next level? And the next level is already kind of 21st century. It's big data. So and it's exactly where we currently our current position on this time scale. So like, okay, you know, programming good. We expect that you know basics of hardware. That's kind of by default. We expect that you know everything related to networks. It's kind of default. It's good if you know some system architecture and can write all the schemes and think out the system as a whole. But to be really on the edge, you need to write something like, I know machine learning and data science. Wow. So this item in your skill set is kind of makes you desired by everyone. And yes, but the question is what's next? And as you see, every 10, 15 years, everything changed completely. So what will be next? And my expectation is the next big thing is robots and virtual assistants. So again, it's not my prediction. This is almost straightforward because you see, like now everyone has virtual assistant on his smartphone, right? You see, okay, I saw some statistics that already now the number of robots on the Earth is already probably bigger than number of humans. So robots are everywhere. And I don't mean human like robots, but I mean all industrial robots like vacuum cleaner robots and all the stuff. So robots are everywhere. Virtual assistants are everywhere, and most probably the next kind of stage of computing engineering will be development of robots and virtual assistants. And let's go through kind of most basic tasks which are currently on the edge in this field. And these bullets I collected from literature overview. I just searched through Google Scholar to see what people really study, what's current topics on research in robots. And I was quite surprised that almost nobody cares about hardware or some protocols and everything related to real technical parts, because still there are some questions in hardware and technical parts, but most of them are already solved. So the most interesting questions people are trying to research are related to robot personality, robot personal embodiment, and multimodal interaction. Multimodal means that the robot not just says you, but it says you, it blinks with his eyes and moves some passes with his hands, okay, probably numerous hands, and some body language and everything else. You can already implement it for robots. The next bullet is social interactive robots. I mean the robot who would like who know how to ask you, to communicate to you, to ask you about how do you do whatever. And the last point is human-robot collaboration. Collaboration is a process when you do something together. And for people, it's something simple. For example, if I ask you, let's move this table together, then our behavior quite simple, right? I will take this table from one side and you from the other side, and then we'll just move it to the direction we agree. But to do that with robots is not that simple, because for robot it's not clear unless unless it has direct order from which part of the table to hold it and where to go. So everything related to human-robot collaboration is really a hot topic. So that was related to robots. Then the same list we have for virtual assistants, right? So the simplest way to make a virtual assistant is just one question assistant, like Siri, what's the weather now? Okay, question, answer. Siri, where Tomsk is located? Okay, same question, same answer. But that's already current stage, and clearly the next stage will be kind of a quite longer communication. For example, this virtual assistant may like read some news for you and just give you some summary, and you can just ask some additional questions. Okay, how is football championship is going on? Okay, it's finished yesterday. Okay, who is the winner? Okay, you don't care. So etc. So building models of conversations is one hot topic. Another hot topic is situation awareness. Again, so if you just ask virtual assistant some question, sometimes the answer might depend on the context. And for that, you need to provide additional information to this virtual assistant, and it's quite interesting topic. So another one is even more interesting, expression of emotions and mood states. This is, we already mentioned on the robot page, but for virtual assistant, it's even more simpler, because for a robot to make a smile or kind of blinking eyes, you need to really implement some fancy hardware which will implement the smiles. But for virtual assistant, which is on the just on the screen, changing the presence is just very simple. So another topic to research. Then autobiography and self-perception is another nice topic. My daughter, when she talks to the virtual assistant, okay, it's okay for her to say, okay, Siri or Alisa, tell me about yourself. Okay, who's your parents? Okay, did you study in the school? Whatever. So, and for next generation virtual assistants, clearly we need to have these answers. And the next research topic is building close and harmonious relations between virtual assistant and the user is also very important, especially for social related applications. And again, to develop everything I mentioned, you need new tools, new development methods for everything, like testing tools, like development, like IDE, and this is another topic of research for virtual assistants. Okay, but this is just beginning of the story. So because the next clear step is when you, your friends, your colleagues make a team with robots and virtual assistants. And that's really become okay, sounds like fantastic. But on the other hand, like I found some papers like 10 years old with some already prototypes and pilots on this topic. So it's already ongoing topic. And quite much has already been done on that. And here is the list of typical questions, typical research topics one would like to study, to dive in, like team dynamics. Okay, if you are just alone, go from point A to point B, then every navigator can build you a trace, right? That's quite simple now and already solved. But if you are, for example, a group of 20, then each of you will get the same trace, right? And if you try to follow it, it will be kind of a problem, right? Because you'll try to go step by step exactly the same path. And for a group, it's not feasible. So you need some algorithm for each team member how to do this dynamics to make it a chaos, right? Then another good topic is models of perception, belief and intention, trust, navigation, coordination of tasks is extremely important and extremely difficult topic. You probably heard about football championship when robots play football. We have such a team in Tomsk, and it's mostly about coordination, right? Because they need to complete the same task altogether. And again, multicultural hybrid, it's another issue because it's already known that if you train a chatbot, a virtual assistant, it gets some culture from the developer. For example, virtual assistant trained and developed in Japan will have slightly different style, different patterns from virtual assistant developed say in Germany, whatever. And when you build a team from this virtual assistant robots, you will face these multicultural problems, and that sounds funny because you will have robots and virtual assistants of different countries, different cultures. But anyway, you will have to deal with that. And the final point, which I will talk more in the next slides, is measuring hybrid team efficiency. So assume you have built a team, you ordered some tasks, you provided them some resources, then after some time you got some result. Okay, the result is never probably as perfect as you expect, but you will need to measure somehow the team efficiency. And even for a team of people, that's not quite simple topic, but for a team of robots, humans, and virtual agents, it's even more difficult. But without tools and methods for measuring team efficiency, you hardly can do anything, because you will need to update probably software, to upgrade some hardware, whatever, but you cannot do that without measuring. So, and next slide is probably a couple words about current applications which are already on the market. The teams of robots and assistants are already used for urban disaster recovery. They do overview of situation. They are part of risky team. And another example I found in papers is related to robot assist inspection for military environment, disaster response, and other related situations. Okay, and so this slide is again about team efficiency. I took it from, okay, sorry, there is no reference, I will add it from the literature. And you see that there is like 10 different factors you need to take into account when you measure efficiency of a human team. First, you need to take into account the organizational setting, because different organizations provide different culture, different stakeholders, different climate. Second block consists of 4 factors related to inputs of your task. What is your work structure? What's your team characteristics? What are team member characteristics? What are task characteristics? And clear for the same team, if you have different tasks, for some tasks it could be efficient, and for other it could be not. The same for work structure. It could be that team is good and the task is relevant, but the resources and communication structure is not developed. So because of this work structure issues, your team will not be efficient. Then there are 2 factors related to process. You need to organize the process of communication, coordination, problem solving in the team, because each time your team starts doing some task, you'll always have some problems, and you will need to have some procedure how to deal with these problems, how to solve them, how to discuss, how to work with conflicts, etc. And for every team, you may need some trainings, some team building, whatever. And for output, again, there are 3 factors. You can measure efficiency of particular team member, like, for example, this one is okay, and this one is okay, and this one approach. And second approach, you can measure the performance of the whole team. You don't care about each person, but if the whole team performed well, then you can say, okay, I don't care about personal performance. But the third important factor is viability, because it might happen that individual performance is okay and team performance is okay, but these guys don't want to work together anymore. So for the next project, they will not be happy to do it again. So team viability is another issue. And as I already said, this structure is for human teams, but clearly you will have the same issues for humans, robots, and virtual assistants. Because when you define tasks for them, the task will depend on mechanical and intellectual abilities of robots and virtual assistants, right? If you design work structure, you'll need to differentiate roles and communications between different robots and different virtual assistants, again, and humans. And you need to develop tools to analyze individual characteristics, right? Like, currently you have numerous like psychological tests for people, and probably you'll have to develop kind of psychological tests for virtual assistants and robots. So the next is team characteristics, like power distribution, diversity, team climate. Again, if you are a computer engineer of the future and you are designing their team of robots and assistants, you'll have to think about power distribution, about team climate, etc. Then team process, team intervention, measurements, everything I mentioned for humans will definitely face all this problem for teams of robots and virtual assistants. So that's probably yes, end of this story. So you see, there is a lot of interesting topics, research topics ahead, quite interesting. What's important, most of them are not really technical tasks, right? So it's not about developing like new hardware or new software. So these topics are at least half like from humanities, like you'll need to study sociology, study psychology, study team models, whatever. So probably the skill set of computer engineer of the future will be really completely different. So you'll have to know how to work with all this stuff. So, and the last slides are related to the computer autonomy. This is just to stress why everything I mentioned is really, really, really important. Because computer autonomy is steady growing. And you see the seven levels. And initially, when people build computers, this was on the first level. Like computer computes something, it computes some possible actions, and then human makes decisions what to do, right? Because I didn't mention that, but it's clear that each time you apply data analysis, machine learning, and all this computing, you need this for decision making, right? So if you try to look on all applications of computing, it's actually about decisions, which decisions and implementation of the decisions which any human need to perform. So on first level, computer just help you in making those decisions by providing a complete set of actions. On second level, computer narrows a selection down. That sounds positive because your work will be simpler. Instead of like 20 or you have sometimes 200 possible options for your decision, you just get only 2 or 3, and then you'll need to decide, okay, you go right or go left. But that's really slightly dangerous because computer eliminated the remaining options, and it might happen that the best option was among the eliminated, right? So even on the second level, computer autonomy has some hidden risks, and okay, it's not that's straightforward, but it's just the second level. And the third level is when computer suggests you a single action, and the fourth level is when computer just suggests and executes that action if human approves. So on the first and fifth level, you see computer allows the human limited time to veto before automatic execution. So computer does everything. So it computes all possible options, it makes decisions, and by default, it executes this decision. And that already sounds like, okay, the fantastic future, but if you think that about it, you will realize that already numerous systems around us are on the 5th level. So the 6th level is when computer does everything and just informs the human about its decision. And 7th, the higher level is of autonomy, is when computer just decides everything and just ignores the human. And again, you might think that's okay, that's not probably possible, but trust me, in engineering, in numerous infrastructure projects, we are already on the level 7. Because, for example, internet, TCP/IP, and all these hubs, everything else it doesn't ask human how to make routing of your message, right? And you don't have any information about it. So everything is done under the hood, and there is no even chance to inform the human about all such decisions because the frequency is very high and the volume of data is really huge. So computer decides everything, acts autonomously, and just ignores the human. So, and we are already, yes, on the 7th level for quite many applications. And for huge amount of applications, we are on the 3rd level. And what's that mean for us? That means that if you say computer decides everything, it really means that computer engineer, I mean software engineer, data engineer, data scientist who designs this computer is actually decides everything, because we are the guys who implement on these computers. And okay, you probably feel proud of that if you're a computer engineer, but what I feel is really huge responsibility, and because okay, no need to to explain the risks and implications if something goes wrong. And that's why really, okay, quality assurance and quality analysis and applying data science to make all the system really working well and clear and transparent is a really quite serious topic. And okay, that's why we organize this summer school. So that's my last slide. Let me switch to the chat to see your questions. Okay. I see some personal questions why I'm in Tomsk. No, because yes, I used to work for Microsoft Research. Now I am Tomsk. Tomsk is really, in Russia there are several capitals. Moscow is kind of main capital. St. Petersburg is the cultural capital, and Tomsk is kind of, everyone agrees, is student capital. So Tomsk is a perfect place to do research, to organize some startup, to talk to students, to teach some new stuff. And so it's in the middle of the rush. So you're kind of in the middle of the earth in some sense. So thank you for question. Okay. Is this conference recorded for later viewing? Yes, it will be on YouTube. And yes. Okay, thank you for question. As for the research side in data science, what area do you think is the best to focus on? Okay, let me try to answer. So, research and education is choosing topic for education and topic for research are completely different tasks. First, because education is wide, so you decide whether you would like to be computer engineer or an artist or sport player, whatever, and then you just have a long list of topics what to study, and just after like 5-10 years you know everything and you feel comfortable in the field and become an expert. This is kind of about education, but research is almost every research topic is very narrow. Like you can't have just okay, I'm doing research on data science. No, that's not that's not good answer. You usually, okay, I'm doing research in data science applications for software engineering. Okay, that's not too wide. You would say better, I would be doing research in data science for quality assurance during development process, but it's again too wide. Typical research topic would be like that. Okay, when you're doing quality assurance, you collect some bug reports, you analyze bug reports, and for huge systems, you may have like 10,000 different bug reports written by different people in different locations. And my research topic is to build an algorithm or tool which will cluster and analyze all these bug reports to figure out the most important underdeveloped areas of our system. Okay, again, that's probably too wide, but at least you see, yes, that research topic must be very narrow, then it's reasonable. Otherwise, it will be more about education, not research. Okay, hopefully I answered. Second question, what do you think of the perspective of robots involving in complicated administrative activity? You know, especially after blockchain, that becomes really possible, because blockchain is the platform which provides you trust, it provides you transparency, and then like most of administrative business processes could be described as a contract for blockchain. So I would really expect that that might happen quite soon. And some people say, okay, this is not technical, but more like social or psychological problems, because people will never agree to be ruled by robots. And I have counterexample. Think about a traffic light, right? Everyone drives car or like use buses, whatever, and some cars are expensive, some are not. Some people are rich, some are not that rich. But if traffic light becomes red, everyone stops, right? Independently of his or her age and salary, whatever. So, and what's traffic light? It's exactly just a quite simple algorithm implemented on quite simple hardware. And this device makes an order, like red light, and everyone follows it. So our civilization already used to follow rules implemented by machines. And traffic light is just the simplest example, right? And so regarding to your question, I really think the perspective of robots involved in administrative activity is quite close to us. Okay, more questions? More. Okay, I left Tomsk. Yes, I really like Tomsk. It's I have another presentation in which I think about where is the best place to build a top-level computer science hub in Russia, and which really proves that Tomsk is exactly the place, because you cannot build it in Moscow, because Moscow is overcrowded. You have all those traffic jams and too many people, too many money, so it's not really nice place for like research activity if you need just silent place. You might think about something like Sochi, and again, perfect place, and our government is currently building a research hub there. But again, there is this beautiful Black Sea and beach and sand, so not good place for research because each time you really try to read the paper, you just go outside the window and decide, no, I will go probably to the sea. And I also used to work in Surgut, another very good place, because it's really probably another computer science hub in Russia, because computer science must be collocated with industry, and Surgut is definitely the industrial hub of Russia because oil and gas industry is located there, but it probably is still too young. And Tomsk is just in the middle of all this, so it's not that cold and that strong weather is in Surgut. You don't have this beautiful sea like in Sochi, so you can concentrate on research and study, and don't be interrupted by beautiful, beautiful clubs and activities. It's not. It's rather small town, so it's not Moscow. We don't have this huge traffic jams, and you can just walk from your home to office like 20 minutes through parks. And yes, I love Tomsk, and thank you for this comment. Investing. So what do you think about develop an assistant which will help you to do investment? So this is already business as usual. So I was involved in some projects where we were together with Iosif and Exactpro. You were working on testing exactly chatbots for financial applications. So this is already many banks try to implement, because again, in investments, there are quite basic rules, and surely a robot can tell you all those rules and try and help. And some part is your decision, and again, robot virtual assistant can clearly show you what are the options and where is exactly your decision and your risks. And what's really important, virtual investment advisor has much higher level of privacy, because each time you tell any person about your money, your savings, it's under the risk. So because no one is perfect. But if you tell that to a virtual assistant, again, there are always issues of information security, but anyway, that for many people that are more comfortable to tell about his or her savings to a robot, but not to a human. Okay, yes, that's about investments. So I'm checking if I missed any question. Yes, yes, thank you. Yes, regarding the information security, I see this holy war topic. Probably we started another. Yes, right. That there will be no privacy because the virtual assistant will tell it immediately to its parent company. Okay, there are some issues. Okay, but still, issue means a good research topic to dive in, to study, to write a paper, to write a PhD. So yes, welcome. Okay, this includes. Do you think that virtual assistants will completely replace humans in the long term, like in customer service or some bank services, or will it become more of a hybrid team? I believe in hybrid teams, because even if it's more such a psychological reason, because for example, consider accounting, right? Accounting was among the first areas in business which was completely automated, because that's not big deal to have this electronic spreadsheet which computes like all these financial operations, which are usually very simple, as like adding something, multiplying something. And currently, all these cloud applications especially for small business accounting, are very simple, very user friendly, and you can learn them like within a couple of days. But anyway, most of my friends who are business owners, they prefer to hire a human who will be responsible. Okay, this human will work with this cloud application, But anyway, the business owner will need someone to talk to discuss this. You know, we have this option, that option. What do you advise? And this is more sociological, more psychological, because surely the owner, the business director, can always find all these answers on the web. Just write it in the chat, in the search system, and you'll find all the answers. But most people prefer to talk to a human. And similarly, I believe it will be in all the other areas. That definitely we will have numerous robots and assistants who can do the job, but you will prefer to have someone who talks to these smart assistants, and then you will talk to him or her. And that's probably the way it will work. It's just my expectation. Okay, Iosif, no privacy. Right, no privacy. Okay, thank you for the lesson. What could be the best area for specialization for someone whose background at PhD? Oh, okay, Guy, you probably need to speak to someone. But that's probably the general answer to everybody. So if you choose area of education, you probably focus more on the status of the institution or university. When you choose master degree programs, you probably should more focus not only on the status and the quality of the institutions, the university, but also on the team, because there are kind of professors and assistants who will work directly. But for PhD, it's even more personal. So probably first choose a supervisor, a person who really does interesting stuff and has good publications, and you feel like personal, like you like to communicate to him, and you feel like someone common ideas and everything like that, and then you start discussing with him or her this topic. So in my experience, it usually takes at least 6 months to figure out the final PhD topic, because there are some more developed areas, some more fresh, some new ideas, some old ideas. Sometimes you need to, and quite many topics are cross-disciplinary, and to figure out really interesting topic, it really takes time. You'll have to study the literature, to talk to people, to figure out some publications to study it. So that's not easy task to find a good PhD topic. And I would suggest, after you know already the direction, like in your case biotechnology, find a good person who a good potential scientific supervisor, talk to him, and then to him or her, and then you will figure out the PhD topic. Okay, thank you, Alan, for question. More questions? Okay, we are probably just perfect timing. I had to finish at 3 p.m. Tomsk time, right? One more question. How do you think research in artificial intelligence pursuing from Tomsk can give international career? Thank you for the question. Okay, you know, the last year changed everything. So currently, when I say Tomsk, most of our master's program are organized like that. People, even those who live in Tomsk, they prefer not to come to the classroom, but listen in distant way, just from the dormitory next block. So, and for this, and we will probably go far in this direction. So we are inviting lecturers from different universities from all over the world to participate in our programs. So international is kind of by default for us. And we are trying to build all this cooperation, to have many international researchers here. So yes, and can give international career. Yes. So Tomsk is international by default, and probably our university is among the top in Russia if you count the number of international students and professors. So we are really international university. So yes. Okay, so now we'll have like a small break. 10 minutes. Anna, are you here? Can you just provide some instructions what to do? So no sound. Iosif is already here. So we'll start in 12 minutes, right? Yes. So in 12 minutes, next lecture. Thank you again. Okay. Goodbye. How to close this? Probably here.
Gosh, it seems like 1,000 sprints ago. I fought my way out of that fall. Started to use ClearTH. Realized I loved it. I know I said no more bugs, but I was really hoping to pull off that one last one.
The software has changed. None of us can go back. All we can do is our best. And sometimes the best that we can do is to start over.
I see all these tests fail.
I keep telling everybody they should move on. Some do, but not us.
Even if there is a small chance, we owe this to everyone who's not in this room to try.
We will. Whatever it takes. Whatever it takes.
Whatever it takes.
Whatever it takes.
I like this one.
Welcome to the Exactpro Systems YouTube channel. Here you can catch up on the latest technology updates in software testing and development for the financial industry. These include the applications of AI and machine learning, DLT, cloud computing, and many other technologies and solutions. You can find the recordings of our latest conferences featuring top-level speakers from global market infrastructures, world's leading banks, and technology vendors. You can watch the Exactpro experts sharing their insights with the fintech community at events all around the world, and with our subscribers in the regular Exactpro Talks segment. If you're interested in the Exactpro test tools released to open source, you'll find a list of tutorials here as well. We also put a new spin on some of the popular shows that we bet you've never thought were about software testing. This channel is for chief technology, information and compliance professionals, product owners, and software quality assurance and development specialists of all levels. Subscribe to our channel, hit the bell button to stay up to date on all the videos, and visit our website exactpro.com if you want to learn more about us. Welcome to the Exactpro Systems YouTube channel. Here you can catch up on the latest technology updates in software testing and development for the financial industry. These include the applications of AI and machine learning, DLT, cloud computing, and many other technologies and solutions. You can find the recordings of our latest conferences featuring top-level speakers from global market infrastructures, world's leading banks, and technology vendors. You can watch the Exactpro experts sharing their insights with the fintech community at events all around the world, and with our subscribers in the regular Exactpro Talks segment. If you're interested in the Exactpro test tools released to open source, you'll find a list of tutorials here as well. We also put a new spin on some of the popular shows that we bet you've never thought were about software testing. This channel is for chief technology, information and compliance professionals, product owners, and software quality assurance and development specialists of all levels. Subscribe to our channel, hit the bell button to stay up to date on all the videos, and visit our website exactpro.com if you want to learn more about us.
Hello, Iosif. So can we continue? Let me introduce the next speaker, Iosif Itkin, CTO of Exactpro. His lecture is a reference architecture for high-volume automated testing. And I would like also thank our director, Rostislav Yavorskiy, because his lecture was very interesting. And I'm also glad to live in Tomsk. And this is a beautiful city and a good team. And I'm glad to be here at Tomsk Polytechnic University to work with such the best people. Thank you.
Thank you very much for the introduction, Anna. I will now switch to my presentation. Okay. So once again, my name is Iosif Itkin. I'm CEO and co-founder of Exactpro. After a short description about myself and Exactpro, I will talk a little bit about high volumes automated testing. Then I will reflect on various requirements for test tools involved in high volume automated testing. There are 7 of them. It is performance and scalability, diversity and unification, resilience and anti-fragility, and autonomy. And then I will introduce the platform, TH2, that we've developed to support high-volume automated testing. I started my IT career over 20 years ago as a software developer. I've moved into performance and load testing in 2006 and participated in co-founding Exactpro on 9th of September 2009, International Software Testers Day. I am also recently started to work with Tomsk Polytechnic University as the head of LOST. LOST stands for Laboratory of Software Testing. I work with other industry events. In particular, I'm co-chair of Fixed Trading Community, MOST working group, monitoring, onboarding, and software testing. And also I'm involved in TMPA, Tools and Method of Program Analysis conference. This year, Tools and Methods of Program Analysis Conference, or another name is Software Testing, Machine Learning, and Complex Process Analysis, will take place in Tomsk between 25th and 27th of November. Call for papers is already open. The conference is delivered in cooperation with ACM, and proceedings will be published in Springer as in previous years. So please do consider submitting your research to TPA conference, and also, of course, come to Tomsk in November. I hope it is not that cold at the time. Exactpro. We are a specialist firm focused on functional and non-functional testing for market infrastructures. Headquartered in UK, we have operations in United States, Georgia, Russia, and at this very moment, we opened 2 additional delivery locations, one in Lithuania and another one in Sri Lanka, to support our existing and new clients. We currently employ over 650 specialists. Exactpro was part of the London Stock Exchange Group Technology Services Division. We were acquired in 2015, but management team proceeded with the management buyout, so Exactpro is an independent company, but continued to provide software testing and related services to many market infrastructures across the globe. At the moment, we have at least 10 of the world's top 20 systemically important exchanges and clearing houses as our clients, from London, of course, to Milan, to Sydney, Tokyo, New York, São Paulo, etc. We work with various types of systems, but the main point is that they are mission critical, they support high volumes, and they require thorough testing. So this one example of the project, what we did for derivatives trading based on NASDAQ for Airbus Skytra. Another very recent, our support for MEMEX members exchange in the US, a new exchange system that is the fastest growing market, equity market in the United States. The case study describing this project is available online on our website, and it contains the picture that represents a typical project where we have a complex system under test that supports multiple transactional and market data protocols, and we connect a complex, sophisticated test harness to explore what's going on with the system. Software testing is understanding the system under test. Warren Buffett said that never invest into something you do not understand. So in order to invest in something, we need to understand it. And the main financial asset for most of the companies in almost every sector at the moment is technology. And all companies in all sectors invest heavily in technology. Software testing is what makes a difference between understanding technology and not understanding technology. So it is a precursor for efficient investment for companies in every sector. And the main process that we use in Exactpro is deliberate practice of software testing, where we are exploring the systems under test, complex systems under test, and provide insights to our clients and partners about their quality. Software testing is exploring software with the intent of finding bugs. It is very important that software testing is empirical, technical investigation conducted to provide stakeholders with information about the quality of the product or service under test. So it is a very human-focused activity, because in contrast to humans, robots have no intentions. It requires human to do empirical technical investigation. However, computers can extend our capabilities in many areas, and software testing is not an exception. So it is possible to use computer assistants to do software testing. Automated testing means computer-assisted testing, and when we do it, we need to expand several of our abilities or features. We need to extend our arms. It is very easy to automate something that looks like an arm. We need to implement sensors to mimic our eyes and other feelings. And we also need to support our brain activity, and it is certainly a more complex endeavor. So it is not that easy. But automated testing means that we need to look into all three to support human brain. Human brain is the best software testing tool available out there. But in order to do testing more efficiently, we need to involve some assistance. There are various ways of doing it, and one of the very interesting directions of research in this area is high-volume automated testing. The term was introduced first in 2002, 2003 by Cam Kanner and his colleagues. There was also a seminar a decade later in 2012, 2013, and I do very much hope that there will be more research now, 10 years more. So what is high-volume automated testing? It is a family of test techniques that use software to generate, execute, and interpret arbitrarily many tests. More detailed explanation would be it is a family of test techniques that empower a tester to focus on interesting results while using software to design, implement, execute, and interpret a large suite of tests, thousands, billions, etc. If we can run arbitrarily many test scenarios and also understand what they mean, we extend our capacity to understand the system under test. We can uncover defects that happen rarely. We can uncover defects that happen only under load. We can uncover defects that only happen intermittently. So we can also uncover defects that happen when there are changes in the state, internal state, data processes, etc., defects caused by race conditions, timing events, etc. So the more tests, the more diverse tests we can run against the system, the better we can understand it. For simple software, it might not be financially feasible, but for mission-critical systems in financial and other sectors, I believe high volume of automated testing will become more and more popular as there is a strong demand for having better, more efficient, and more reliable systems. So recent advances in machine learning have two originating factors. The first one is data volumes. So data volumes increased significantly. So many machine learning algorithms were known for many years, but only recently humanity accumulated lots of cat and dog pictures and also data in other areas. And also we now possess more computational power than ever before. So these quantitative changes allowed to make a substantial step in improving the quality of machine learning. And when we think about applying data science and software engineering, data science in software testing, the two main precursors of doing it are the same. Just data volumes and computational power. So whatever test tool we plan to use for high volumes of automated testing, we need to make sure that it has sufficient computational power. And we also need to make sure that we produce large volumes of diverse test execution results. Without it, it will not be possible to apply machine learning to support humans in software testing. These are examples of the modern system's non-functional requirements: daily capacity, peak rates, and round trip times. It is typical modern exchange system, a typical system under test that we in Exactpro used to work with. So there are hundreds of millions of transactions per day, and response times are within hundreds or double digits of microseconds. It means that when a human blinks, so it is the time period for blinking of an eye, it is 200-300 milliseconds. It is 3,000 times slower compared to the time that it takes a transaction to pass through all internal components in the modern exchange system and get back. Modern systems possess high performance and scalability. It is achieved through using duplication for as many components as possible. And on the picture, there's a chart from a latency paper from NASDAQ company on how exchange system is organized internally. So we can see that these enormous performance characteristics are achieved through having duplication of access points where clients or trading robots are connected to access points, and also through routing where we can partition data between many matching engines. So when we work on software testing for such systems, and when we are trying to build software, to test software, when we try to mimic performance and scalability of the system under test in software testing tools, we need to have something that will be very similar to that. We will need to have access points connecting to the system under test. We will need to have matching and validation engines that will process the data. And it is necessary to have a routing layer between access points to the system under test and various validation facilities. To a degree, extreme modern software testing tool should look like production system, like exchange or algo trading system or market surveillance system. So when we look at creating something like that, we need to introduce architecture that will support partitioning, that will support routing, etc. Now we go. Then two very, very important points in requirements for test harnesses is diversity and unification. So on the point of diversity, we are building software to test software for more than 11 years now, and we've built many tools. Some of them are in open source to do functional testing, to do non-functional testing. But the idea is when your only tool is a hammer, every problem looks like a nail. And diverse perspectives give you more. For example, for functional testing, for many years we used a software testing tool called Selfish. Selfish is the idea behind Selfish is to take Excel files with keyword-driven actions and execute them against the system under test, receive messages, normalize them, and analyze whether we received what we expect. But all the testing tools built on this principle, they consider the system under test as Excel sync. So we send Excel in, we get Excel out. It is a very valid software testing approach, but it is one limited perspective. Or non-functional testing, we needed to cover non-functional requirements of hundreds of millions transactions per day. So essentially, we've created load injectors capable of producing these hundreds of thousands transactions per second. To be fair, they look at the system under test as a sink, as a black hole, or not really a black hole, but as something that we bombard with lots of messages and see whether it will survive or not. It is also a very, very valid perspective, and it also very useful to understand that the systems will be able to support production level loads, but it is once again a limited perspective. So diverse perspectives, when we look at a single thing from many perspectives, we get more information about it. So when we create an army of software testing tools, they should not be the same. They should all be different to provide different information about the system, because you will not be able to extract lots of different information with a single hammer or many hammers. You will extract exactly the same information. An interesting thing is that what we need to do is not just produce many different diverse test tools, but also combine them into various permutations. Think about it. So the diversity of life on Earth is related to various combinations of just 4 amino acids. So what it means from architectural point of view, it means that different access points into the system under test should be diverse. So the more programming languages they'll be written with, the better. We do not need one ideal access point into system under test. When we create a production algo trading robot or a search engine or something like that, we need to create one ideal software. But when we create software testing tool, we do not need one ideal software. Instead, we need a wide variety of non-ideal tools. So the architecture of the system needs to allow many diverse access points. And to have it, we are trying to use microservices architecture, and we are also trying to use protocols that will allow us to create access points and other components in different programming language. But from many different access points, the data goes into correlation, into matching, into analysis phase. And there we need to have some normalized behavior ability to have a consistent way of working the data. There is a very nice video from Andrew Ng about what is necessary to turn your company into AI company. And one of the main points is to have a universal data warehouse. Why universal? It is because all the data collected as a part of data accumulation strategy need to be accessible in some consistent way. So if we do not have consistent way to access the data, we will not be able to create many analytical processors or many analytical queries to better understand the data. So on the left, we need to increase diversity as much as possible. On the right, we need to limit diversity. We need unification, universal data warehouse. And in the middle, we need to have something that will allow us to combine what we have on the left and what we have on the right, and this is the routing layer. Also, by combining various access points and routing components, what we can achieve more permutations and more diversity and ability to execute more tests and more interesting checks against the system under test. The next two is resilience and anti-fragility. What is clear is that in very important system, when something goes wrong, it usually goes wrong because not one subsystem failed or one component failed, but because there were multiple simultaneous problems. So usually black swan is when people made not one, but many mistakes. And this a single protection layer would have prevented it, but none of them worked out. The idea in software testing tool in huge diverse regression libraries is that we do not need a single test or a single test scenario that will pick up every problem. So instead, we need to make sure that the problem will be picked up by subset of the tools, but not by a single tool, but by multiple tools. So it is necessary when working with mission critical software and when we are creating test harnesses for mission critical software to put deep multi-layered test validations. So if we check something at our access point, it should not prevent us from replicating the checks, maybe in some slightly different manner in routing or in matching parts of our systems. And then if the problem was not captured in real time at any of these points, there should be data services and analytical queries against the data warehouse that will try to identify gaps in the test coverage. So it is very important to duplicate checks and ideally write these checks in using different languages and different coding approaches. So in some cases it can be a script, a Python script. In some cases it can be Excel model. In some cases it can be a streaming SQL query, etc. So the idea is that we are building a diverse network of checks that will try to pick up a defect, and if one of the components will miss the problem, others will find it. It is also important that in software testing we are not dealing with the good situation when everything goes according to plan. So software testing is always a pain. So it means that there will be crashes, especially in access points, but in other internal components as well. What is very important for high volumes of automated testing is that a single crash inside the system will not affect macro stability of the test harness as a whole. So when we are creating test harnesses for this particular reason, we need to make sure that the system is anti-fragile. So we have constant outages of many test tools, but overall, the test harness continues to hammer the system under test and extract more and more information from it. And a side effect of it, to a degree, is autonomy of individual components, access points, routers, matching engines, etc. Why? Because it is a very common approach to software test automation, approach based on assumption that we can fully control the system under test. That when we start the test scenario, we restart everything clean, and then we have full control of what's going on. And then we put transactions, predefined transactions. We check that the response matches our expectation, and that is it. But it is not an efficient approach in high volume of test automation, because as soon as you assume control of any component over the system, it means that you have a limited scalability. So you already have a central point that slows down everything else. Instead, we need to assume autonomy for most of components inside the test harness. So most of test scenarios should not make assumptions that they are alone in the system under test. The test scenarios that make this assumption, they very much limit our ability to execute scenarios. On the other hand, scenarios that and checks that work in assumption that there is always traffic in the system, they allow us to execute many tests in parallel. So execute the key strategy of high volumes of automated testing. It is very important to have partition-based routing to support it, because we need to make sure some of the verification, some of the checks will not be able to process all the traffic. In high volume environment, no single component will be able to process all the traffic. So we need to design routing inside the test harness in a way that the data will be distributed between many components accordingly. So when some test tool is not performant enough, it will only receive enough traffic that it is able to process and no more. So, and this way of writing test scenario differs from what is usually used for test automation. It requires separate training. It requires a slightly different mindset. But eventually, the more tests we would like to run, the more autonomous the components inside the test harness should be. H2 is open source platform that we specifically designed to serve as the reference implementation for these ideas. It is available on GitHub It is a very active project. We have at least 55 contributors at the moment. We have 92 software repositories. It was deployed into open source last December, and we are working on expanding TH2. TH2 is a platform and technology agnostic. It is possible to create microservices within it using different programming languages. At the moment, TH2 targets specifically financial systems due to historical reasons and our years of working with market infrastructures. We currently use it mostly in financial sector. We use Cassandra as a unified data warehouse to store results of all transactions, to extract data from test cases, logs, requirements, etc. Storing the data allows to use data services to support machine learning-based testing approaches. The tool is already deployed in many of financial services infrastructures, and our target is to make sure that all our clients are migrated to TH2 from the previous versions of our software testing tools. Thank you very much. Thank you for participating in summer school, and also thank you for watching the school on Exactpro YouTube channel. We have quite a lot of information here. All recordings for the school will be available in the channel along with many other information. So please do help us to promote school materials by liking and sharing this stream. Thank you very much. And I can now look if there are any questions. Okay, there are no questions so far, but I will answer the last one for Rostislav. How do you think research in artificial intelligence person from Tomsk can give international career? First of all, Exactpro is an international company. We are headquartered in UK. We have clients across the globe, and we have offices in 6 different countries. We work with Tomsk Polytechnic University on creating laboratory of software testing, LOST, and the very focus of this laboratory will be applying machine learning to software testing. We also organize international conference in Tomsk, TMPA, and eventually we will also, I hope, create an international master's program dedicated to software testing and machine learning together with universities from other locations. I hope it will be Sri Lanka and Georgia. Thank you. Okay, so there are no more questions, and then we'll see you tomorrow. Anna,
yeah, thank you, Iosif. Thank you very much, and thank you all attendees for being with us and for your questions. Then we propose you to work in groups to participate more actively. It means you will divide it in groups of 10 participants, 10 people. So together you will be take lecture notes in brief, just 5 or 7 highlights, main ideas related to lectures, to the lecture topics, so all the information about your group and how to work together, I will send you via email or Telegram chat. Please join us via Telegram chat, and we will send also the new link to the our event that will be tomorrow, because tomorrow we will start at the same time, but the link will be different. So now this is all. Thank you very much. So please feel free to contact me and our organizing team. Thank you and bye-bye.